Hey everybody, Carlos here. I'm just gonna wait a few more minutes to get this situated. It looks like the lighting is right. And well, one more time, my name is Carlos. I'm a math tutor, tutoring expert. I'm also a Latin dancer and the co-founder of LeagueofTutors.com. And what I would like to do, as you probably have seen, if you found me on Facebook or Twitter already, what we're trying to do, we're trying to come up with a series of live streams, video live streams, to teach and share with the world some of the magic and math tricks that I have collected over the years. So that said, I wanted to start with a quick recap of what we are doing. Last week, we started talking about thinking outside the box. So if you miss it and you would like to learn more, go ahead and find me. Here's my handle again, at CJ Roman. And to keep things simple, our goal here is to think a little bit differently. We want to approach mathematics in a very different way. Today, we're going to share with you some tricks, a couple of tricks. Then we also are going to talk about the big secret. What is, in my opinion, the big secret in terms of math? Why some students succeed at math and why some others don't. And again, if you are following and if you are actually trying to learn more about these things, just remember two things. Mathematics, or success at math, comes down to two things: the right teacher at the right time and confidence. And I want to invite you all to participate. If you see something that you like, if there is a trick, a particular trick that you're interested about, and you miss it, feel free to include us. Use hashtag mathwithconfidence. Find me on Twitter, and I'm happy to answer some of your questions. Feel free to participate as well. All right, so let's get started. Last week we're talking about thinking outside the box. Today, we're going to find alternate ways to memorize, for example, the multiplication tables. And many people are telling me, or I actually received a couple of emails saying, Carlos, but why in the world are we doing something as simple as the multiplication tables? And the truth is, we're doing that because we need to start with our foundation. And in fact, most of our live streams or video streams are going to be on foundations. And you will see how, by actually mastering our foundations, we can build upon them or on top of them. So, let me show you how I teach the multiplication tables. If you have a child or if you know somebody that is struggling with that, this is probably the best way to do that. Last week we did the multiplication tables of 9. And today, I'm not going to spend the time doing 0, 1, and 2 because those are easy. The same thing with 5 and 10, right? We are going to focus on the ones that most students or people struggle with, okay? So I'm going to start here. Hopefully you can see my board right there. The most common multiplication tables that most kids, fourth graders, 5th graders, or why not, struggle with are the multiplication tables of 3 and 4. And I'm going to teach you two simple tricks that you can use even with some of those students. Ready? If you have seen some of these tricks, bear with me. I'm sure I have a collection of those that chances are you have not seen all of them that I already have, okay? And I'm willing to share with you here. So let's start with the hashtag, right? The famous hashtag. If you want to teach the multiplication table of 3, what we want to do, we want to write the numbers from 1 through 9, starting from the bottom, right here. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you have that experience already of teaching elementary school kids, chances are you know that the attention span is limited. So this is what allows you, in a fun way, for them to start remembering and memorizing these tables, all right? So we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9. After that, you just have to remember the row. So you're going to write zeros for the first row, ones for the second row, and twos for the last row. Right there. And then the last thing your child or you have to do is read them, right? So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and just keep going. 3 times 4 is 12, 5, 15, 3 times 6, 18, 3 times 7, 21, 3 times 8 is 24, and finally 3 times 9 is 27. And it's that simple. That's what we have to do. And as I said, if you already know this, you're already familiar with this trick, no big deal. At the end of the day, you want them to start memorizing simple approaches, right? Because otherwise they will forget. So hopefully you like this simple trick. Another one that is actually very difficult to master is the multiplication table of 4. And I really still don't understand why. Many people have tried things like skip counting and doing things like that, which is not necessarily wrong, but I have found that it's easier if we can break things apart, right? So why don't we do this? Instead of doing the hashtag or pound sign, let's do 2 plus signs. Okay? So I would normally tell them just go ahead and write 2 plus signs, and then you do something similar to the previous example. I'm going to write, but instead of starting with 1, I'm going to skip count by 4. Actually, why don't we do this? Just memorize this order. 2, let's skip by 2. 2, 4, 6, 8. Skip count by 2. It's going to be easier that way, right? So 2, 4, 6, 8. And I'm going to do that also on the other side. I'm going to move a little so you can see it. And I will repeat the process. You want to make them identical. So 2, 4, 6, 8. That's it, right? And what I normally like to do, I like to tell them stories. If I was teaching this to a, for example, 3rd grader, I will tell them something like, you want to be able to connect these two with a bridge, right? So I will say that that is the bridge between these two. The rest is piece of cake. Just similarly to what we did for the multiplication table of 3, we're going to start with zeros. So 0, 0, 1, 1. A 2, because that's my bridge, right? So I started 0, 0, 1, 1, 2, 2, 2, 3, 3. And that's it. So one more time, you start 0, 1, 2, 3. And the rest is just a matter of reading those, right? I'm going to go back a little just to help you remember. We started by skip counting by 2, 2, 4, 6, 8. Then we did another one similar to that one, identical, 2, 4, 6, 8. And finally, if it's the first row, we start with 0, 1, I'm going to move this so you can see it, 2, and then 3. And I will have them read it and memorize it and do it as many times as they need to, right? 4 times 1 is 4, 4 times 2 is 8, 3, 12, 4 times 4, 16. This part is interesting. 4 times 5, because it's my bridge, is 20, right? And then you continue. 6, 7, 8, 9. And that's how, hopefully you can see it again. One more time. So that's times 1, times 2, times 3, times 4, times 5, times 6, times 7, times 8, times 9. And these are two basic tricks that you can teach. The truth is, if the trick or your approach is not simple enough to the point that a child can understand, chances are we don't have the best approach. But that's it. And I normally just have them, I have games. We normally will try to see who can fill it out the fastest in a matter of 30 seconds or a matter of 15 seconds or who knows. At the end of the day, you can come up with games if you want to, but we want them, by repetition, to memorize the tables, right? That said, the next part that I think we should talk about is the big secret. How is it possible to use the same principles in something as simple as elementary school, 2nd, 3rd, 4th grade, 5th grade, up to calculus? The truth is, it is possible because of the big secret, and I call it that my big secret, hopefully you can see it there, my big secret is that everything is a puzzle. And my students actually really like this when I tell them, you know what, the big secret is that everything is a puzzle. And I normally just bring something like Legos. Everybody knows Legos, right? And many of our kids actually love Legos. And here's the example. And this is the reason why it's actually very, very, very important in mathematics. When I started looking at my math, whether it was trigonometry, calculus, whatever, and I started to look at these things as puzzles. And bear with me here, because I'm sure you might be thinking of puzzles in a very different way. I started talking about bits and pieces. I started thinking about parts, right? And that made all the difference. And I would like to show you how that is possible. But when you look at a Lego set, right? Some people will actually just look at the whole thing. The whole would be the house. What many people forget is that a house is made out of parts of windows, or you name it, different blocks. And if you can look at everything that we have or we're surrounded by is actually made out of parts. And if you remember our challenge when we were talking about in how many different ways can you think of the number 1, or can you write the number 1, we were also, in a way, coming up with parts and pieces, right? So, let me give you a good example about this. And for example, if I give you the number 15, if we're starting to think outside the box and we're successful at thinking about bits and pieces, that means we can take them apart. That means we can break them, right? Then it's easier to understand that I can write 15 as 10 plus 5. If I wanted to, it depends on my application, or depending on my goal or my end result, or what I would like to accomplish with this number, I could also write it as 15 times 1, right? 15 times 1, 10 plus 5. You could also do 5 plus 5 plus 5, right? And these are just alternate ways or other options to write or think of the number 15. And these are just a few. We have talked about how there is an infinite number of different ways to do this. Now, it all depends on what we would want to do with these things, right? And again, this is flexibility. We want to create math flexibility. And those that are already teachers, or those that already know what I'm talking about here, this is the origin of expanded form, right? If you're familiar with Common Core, well, you probably have seen this before. Or if you're a parent and you have a child, chances are you have seen this before, right? Expanded form. That is just one of the approaches, one of the ideas that come from seeing a number as a number that is made out of other parts, or made out of other numbers. And so now it's relatively easier, using this example, to add, to subtract, or to do more calculations, more complex calculations, right? Here is a perfect and simple example. So you guys, many of you might already know what I'm talking about here. But if I write the number 1025 and I want to add 372, in our minds we can start actually breaking this apart and thinking, well, this is 1000 plus 20 plus 5, right? So this is 1000 plus 20 plus 5, and then now this is the same thing as 300 plus 70 plus 2. And now it's actually easier to add. You can do that in your head, because now 5 plus 2 is 7, 7 plus 20 is 90, 300 plus 1000 is 1300. So that will give you a final result of 1397. And some of you might be thinking, Alright, Carlos, but that's basic math, right? Yes, it is. But the power of this thing comes when you want to multiply, right? Faster in your head. Here's an example. What if I wanted to multiply 23 times, let's say 7, right? Many people will actually start freaking out here with this one. But if we do it the same way, if you can break apart the 23, break it apart as 20 plus 3, and now we can multiply that 7 times both of them. Well, 7 times 20 is 140. 7 times 3 is 21. So now you can just add, right? Because 20 plus 3 is 23, so I can just add that combination, 161. And that's how we can use that concept of decomposition. That's how we can use that idea of breaking things apart to help us do more complex math. For those that are taking more advanced levels, let's say algebra, or maybe you are taking the SAT or the GRE, or you name it. If you're taking a college application exam, or you're doing pre-calculus, for example, chances are you might see something like this. If I give you a number, let's say 2 to the k plus 1, right? And many of you might be thinking, what in the world is he talking about? Well, if you are taking some of these classes, you will remember your laws of exponents. Your laws of exponents say that if you multiply two numbers with the same base, let's say multiplying, let me go back a little, but to keep it simple, let's say I have 2 to the third power times 2 to the fifth power. We know that the law of exponents says, here, I'll make it even easier for you guys so you can actually see what I'm talking about. You have x cubed, or x to the third, times x to the fifth. Laws of exponents say you just add the exponents, right? So we have x to the 8. Because you just add the exponents. 5 plus 3 is 8. So for those that are taking those advanced classes, or those that are taking college application exams, when you look at this, you need to start to think outside the box, and you need to be able to decompose, to break apart these numbers. For example, if we follow the same idea, well, I could say that I can write x to the 8. Here, let me move this over. In the previous example, we had x cubed times x to the fifth. You add the exponents, and that gave me the exponent there, right? So, following the same principle, if I wanted to break this apart, what prevents me from saying that x to the 8 is x squared times x to the first times x to the first times x to the... So let's see, we have 2, you have 2, 3, 4. So why don't we do a 4 here? Do you see that? So now we have this madness, this crazy thing here is the same thing as x to the 8. So, following that same principle, if you see a question like this, break it, right? If you are adding the exponents, then multiply it using two numbers, 2 to the k times 2 to the first. Hopefully you can see that. I'm talking about how if you have exponents that are adding, feel free to break them apart. 2 to the k plus 1 would be the same thing as 2 to the k times 2 to the first. You have two bases of the same, they have the same bases but different exponents, and then you just add the exponents. I'm sure at this point I probably lost a lot of people. Many people probably got confused because we started dealing now with variables. At the end of the day, there are other techniques, there are other tricks that we would like you to learn, we would like you to master. But as I was saying earlier, we want to start with the very basics, strengthen our foundations as we go, and we will be able to go from elementary school up to calculus at a high school level, an AP calculus class, IB maths, you name it. We will be able to excel at any level of mathematics. that said, I would like to challenge you this week to look for these bits and pieces. Let me give you a hint. Look for something like negative space. If you know what I'm talking about here with negative space, chances are you understand now the idea of having multiple pieces and parts in maybe a picture, right? But I will suggest, if you don't know what that is, look it up. That will be your homework. Look it up, find out what is negative space, and actually find some cool, type it in, go online and type it and find some cool examples of negative space. Chances are you will get a bunch of company logos, or you will get a lot of art or pictures, and it'll be a fun thing for you to discover what is negative space. We'll be using this next week at the same time, but again, remember, we need to think outside the box, and then we want to think of bits and pieces. If we're successful with that, we will be successful everywhere. And that said, if you need accelerated results, or if you have any questions, feel free to contact me, find me on Twitter, send me a quick message that way. But above all, if you need help with science, English, with college application exams, programming, whatever it is, do not hesitate, and please don't wait. Find us at leagueoftutors.com, where we're collecting and we're actually finding and training the very best tutors for you. And the best of all, your very first lesson is only $5. Alright, my friends, if you don't have any questions, or if you have questions, feel free to contact me. I look forward to seeing you next week. Have a wonderful day. Bye-bye.